This is another function that I need to know how to find the domain of by looking at the function. A rational expression, also known as a fraction, is an expression that has a division bar in it. This particular problem, you see the x minus 5 in the numerator and then the x squared plus 7x plus 10 in the denominator. So it needs to have a numerator and denominator to be a rational expression. Fractions, or rational expressions, are not defined if the denominator is 0. We've seen in an earlier example that we try to divide a number by 0 and that was undefined. So to find the domain of a rational function, then you need to set the denominator equal to 0 and solve. The domain would be every real number except the values that you got that made the denominator 0. So in this case, to find the domain, I need to do a little work first. I don't care about the numerator, so I'm going to write who cares here. I don't need to worry about the numerator. The denominator needs to be set equal to 0. We have not yet solved an equation in this particular form in this class. We will do more equation solving of this form later on, but for now, let me remind you of some algebra that you have learned in another class. To solve something that's a quadratic equation, quadratic means that the highest power on your x is squared. You want to get 0 on one side, which is already done, and then you want to factor the non-zero side. To factor something that's a trinomial, this left-hand side is a trinomial because it has 3 terms. It has an x squared, an x, and a constant. Then you're going to factor by using backwards FOIL. In other words, the first thing we want to do is find 2 values that would multiply to x squared. This would be x and x. The next thing we want to do is find factors that would multiply to 10. Now, if there is an understood 1 in front of x squared, you can specifically look for factors of 10 that would either add or subtract to 7. Well, factors of 10 could be 10 and 1 or 2 and 5. If we choose 2 and 5, then 2 times 5 is 10 and 2 plus 5 is 7. If the signs were both positive, we would get a positive 10 when we multiply and a positive 7 when we add. So this is the correct factorization for the x squared plus 7x plus 10. Once you have the factors to solve, you set each of these factors equal to 0. Solving, I'm going to subtract 2. That would result in x equals negative 2. Solving here, subtract off the 5. That will result in x equals negative 5. I'm going to draw a picture of the domain of this function. Essentially what we have said is that the domain can be every real number except negative 2 and negative 5 because these are the values that make the denominator equal to 0. So a picture of your domain would look like this. We would have negative 5 to the far left and negative 2 to its right. I've used open circles to indicate that those 2 values cannot be included in my domain. To write the domain in interval notation, I will use this picture to assist me. The picture goes all the way to the left, so I would start at negative infinity. It goes all the way up until you get to negative 5, but negative 5 cannot be included. So I would go to negative 5. To not include it, I would use a parenthesis. Now, if you are connecting more than one interval together, we're going to use what we call a union sign. Then I would need to go from negative 5 to negative 2, but the negative 5 and the negative 2, neither one of them can be included. So negative 5 to negative 2, use parentheses around each of those. Put another union sign, and then from negative 2 you go all the way to the right, so it would be negative 2 to infinity. Use parentheses around your -2 since it's not included. Also be sure to use parentheses around your infinities, both the positive and the negative, and this would be your domain. We see that this is a little more work than on the other problems, and we see our domain notation is a little more complicated. Now, that is all the work that you need to do for me on a test or in your homework. But to justify this, I'd like to go to the calculator. Our original function was f of x equals x minus 5 over x squared plus 7x plus 10. To put this in my calculator, I absolutely must use parentheses around the top and the bottom of my function. When I type it into the Y1 menu on my calculator, it would look something like this. Open parentheses, x minus 5, close parentheses, divide by, open parentheses, x squared plus 7x plus 10. So let's go do that. If you have a function in there, clear that function out. Open parenthesis, x minus 5, close parentheses, divide by, x raised to the second. I have to right arrow to get out of the exponent, plus 7x plus 10, close the parenthesis. Just so that I have an idea of what my function looks like, I'm going to do a zoom standard first. I can always adjust that later on. And there is the function. Now, that particular function, some of you on your calculator, you may have a strange looking bar in between these two values. That's actually not a piece of your graph. The graph that I have on my calculator is the graph that you need. If you do have those strange bars, I'm going to say in between here, in between there, you just kind of have to ignore them. So the general idea is your graph looks something like this. Okay, and it turns out this is something that we will learn at a later date. There is what we call a vertical asymptote occurring at -5, which is an imaginary line that your function cannot touch or cross, and the same thing is happening at -2. There is a vertical asymptote that your graph cannot touch, cannot cross, and that's the reason that the two values, -5 and -2, are left out.